Namaskar my dear friends. Let us talk about how we can enter schematic in OrCAD. So as we have already seen, entering schematic in OrCAD is quite easy. We have to just find out the components from our library and then place in a schematic page, right? Now we'll try to identify how we can make our libraries. Let us say we need a resistor or capacitor or inductor or whatever the component that will be required to design this particular schematic that we have already done in our, let's say, pen and paper. Now we want to enter that schematic in OrCAD. So before that we will have to have a library, right? So let us say I have added one library. It is having almost all the components. Okay. So what we will do is we will try to understand how we can make libraries like resistor or capacitors or aluminum capacitors, maybe diode or maybe some buzzers, or maybe like a connector like 2-pin connector or 4-pin connector, or maybe some push buttons or transistors or MOSFETs, or let us talk about any like ICs or something like that. Okay, so we will start with very basic ones. Let us say we'll talk about resistor. So what is the first step that you have to understand is, let us say we will make one resistor and we'll try to have in the library like 0402, 0603 and other package as well, like, okay, so whichever is needed we can simply utilize them. Okay, so similar to that other components also we will see. So what I'll do, I'll just add a simple OLB file. So let us say I have system library file, I have made it for you guys. Okay, so you can see it has very less number of components. Okay, now what we will do is we will try to put up some like components in that. Okay, so very first thing, let us say that we want to add a resistor. Okay, so let us say I have a resistor here, so I'll take up from there. Okay, so I'll just take one resistor and then I'll paste in mine. Okay, paste. So if you open, this is the library window that will open and you will see that you can have like what is my part numbering, what is my PCB footprint, and what is my this thing. So before doing that job, what I will do is, let us say I want to make 0603 resistor. Okay, so for that I'll just go here, save as, and I'll just put it as 0603. If you want you can have a different library OLB file or something like that, that doesn't matter, it's up to you. Okay, but I'll keep it in the same. So let us say I'm going to put it in same. So I have now 0603 resistor. So what are the changes that I need to do? I will have to make my PCB footprint suitable to 0603. This is not mandatory. If you want you can have only one resistor for all the circuit design and you can keep changing the parameters separately, but it is always good to have like a separate resistor for different functionalities. Then if you want you can have part properties, like I have put here description, manufacturers, manufacturer part number, all these things. If you want you can add another properties as well. Okay, let us say if you want to put ROHS information, ROHS, so you can put it yes or no, something like that. Okay, then you can put it yes. Understood? So this is how you can put. I'll just put O as a small so that it will be nice. So you will see that it is looking like ROHS this thing. Got it? So this is how you can make your RES 0603. Now if you search here, so you will see you have system library here, and here we have RES 0603. So you press it here and this one has come. Understood? While putting in the schematic you can change the values, or you can change the like description, manufacturer part number, everything you can change one by one, and this is how it will become your particular library. So I want to make it a general like resistor here, so that I have not changed any permanent parameters. Okay, so what are the other things that you will be needing? Just list out these components in your library so that it is easier for you to put any schematic in future. So all these kind of resistors you make, Then you make all this kind of capacitors like 0402 package, 0603 package, 0805 package, 1206 package, or 1210 package. Okay. Then you be ready with your like LEDs, let's say green, yellow, red, all these LEDs. We must have to have diodes or Zener diode, like TVS diodes or something like that. We have TVS diode, you can keep it something like this. Okay, let's say this. And then we have Schottky diodes and all. You can have diode pair as well. Let us say we want to have something like this, common anode diode. Okay, or it can be something like this, common cathode diode will be there. All right, so like that you can have. So let's say pin number 1 2 3, or let's say 1 2 3, like that it is there. So this kind of like general values, like symbols you can have. Now let us talk about connectors. So you must have in your library like 2-pin connector, 3-pin connector, 4-pin connector, or like all general values pin connectors that you can have in your schematic. More importantly, you must have in your library like MOSFETs, let's say N channel MOSFET, P channel MOSFET. If you want, you can put down your diode as well. So the inbuilt diode is there in the MOSFET these days. So this thing also you can put. Then similar to that we have transistors like NPN, PNP. Then you can also utilize like in your library, keep it very frequently it is used, like fuses will be there, then MOVs will be there. Okay, and we have inductors, ferrite bead, common mode chokes will be there. Okay, and similar to that, let us say we have transformers, whatever else ICs are there, like let's say you want to utilize some linear regulators, switching regulators. So it all depends on manufacturer part number. So all the linear regulators will have different uh, like libraries. It cannot I mean one symbol cannot serve for all the linear regulators. So uh, it will depend on the part numbers. Okay, similar to that we can have microcontrollers which you are utilizing for your system designs, test points, mounting holes, all these things. Then we have like optocoupler, bridge rectifier, and everything. Okay, so all these things actually I have done it for you here, and you can utilize this library for that purpose. So let me just give you an example like how do we do that. Okay, so let us say we utilize one LEDs. Okay, so this is my LED that is there. So if you want to like save it with a part number or something like that, what you can do is go file, save as, and let's say LED 3. Okay, and if you want you can put it in your own library. So I'll just put it in my system library and then press it OK. So you will see that in your sim library file that LED 3 has come. Okay, got it. Now if you want you can utilize your caliber to make the changes in the particular graph. Okay, so this is called graphic orientation. So let us say this is my pin. So pin, if you want to change, you click on pin and you can make it, let's say, line, so it will become longer. Okay, so you can see the pin has become longer, 3 lines. Okay, similar to that this also can be made longer. So what you can do is go and make it line. So this is how you can make it line. Okay, now let us change another thing. Suppose you want to add a line or something like that. So go place here and then we have line. Okay, so this line if you want you can place it like this, so it will be placed like this. So it is up to you like what do you want to do. Okay, let's say you want to place it like this also, so it will be placed, and you want to move it like this, you can move it, but I don't want to do that, so let's remove that. I will give you an example of making an IC. It will be nice for you to understand like how ICs are made. Okay, so let me take that. I'll just remove that. No need to save that. So let us take I will take an IC which is a battery charger IC, and this is the like typical application for this particular IC. So what I will do is I'll try to develop this particular IC which is there. Okay, so for that I need to have an understanding of how to make this particular circuit, I mean make this particular symbol and name all the pin numbers. Okay, so for that what we have to do is we have to open OrCAD. I will always suggest you that you take any symbol which is existing, okay, and just open them and save it as, okay. So you can just save it as, let us say I can take one IC or something like that if it is there. If it is not there, any symbol is fine for you, okay. So what I will do is, let us say I will just take UCC, okay. So this is my symbol that is there with me. Now I am going to go save as and save it as with the name of the IC, okay. So the name of the IC is LTC4080. So I will do that. LTC4080. LTC4080. This is done. If you want, you can put it in your library, so it will be easier for you to find out, otherwise you will be mixed up. Okay. Now based on the information of the IC, you can change the like package and all those things. So this makes it clear. Now let us say it has 10 pins, so I will just delete all of them so that you can have a from the scratch you can have an understanding. If you want, you can pull it down or you can make it little small, okay. So all the things you can do. This is my outline and this is my rectangle, okay. So if you want, you can delete the rectangle, okay. So this is how you can do. So from scratch I am going to tell you, let's say I am going to delete the value. So value is deleted, and you can see it has like description and everything is made, so I'll just delete all of them, okay. Or let's say I'm deleting this Texas Instruments, part number, everything is now normal, okay. Alright, so what is the first thing that we have to do is, we can have one rectangle so that it can give me an outline of this particular symbol. So what I'll do is go place a rectangle. So I'll just take it here and place a rectangle, okay. So this is done. Now we need to have 10 pins, right? So I can go pin, so I can take it here, like a pin 1, and then let's say pin number, so that is 1, and then press it. So one pin 1 will come, then 2, 3, like that I can keep on going 10 pins. Understood? So this is one method to take 10 pins. Got it? Another method is, let us say go here and pin array, and let's say you want, let's say P1, and then a starting number is 1, and I want number of pins as, let's say 10. So it will give me 10 pin totally at a time. Or otherwise I'll just put it 11 so that I can have exposed pad as well, okay. And then pin spacing is 1 I'll keep, and then let's say press, so I have total 11 pins available with me, okay. Understood? So since it is not enough, that's the reason it is going like this. Otherwise I could have very easily like placed in here. So this is the two methods that is there to keep like pins in the symbols. Understood? Now what I will do is, I will just name them accordingly. So let us say I have pin number like 1 as bat, so I will just keep pin number 1 as bat. Similar to that, all the pin numbers you can like name them properly so that it will be easy for us to understand like which pin for what purpose, okay. So as you can see, you can like keep on writing the pin names properly. So this is program pin, PROZ, and then we have ACPR pin. So we have ACPR. However, this has to have one like a bar over here. So you can press this forward slash. So this will make it bar. So this is how a bar will be seen over that. Even EN charge is having bar. So what I will do is, after each character you have to give this one, okay, forward slash. So it will give you bar. Similar to that, pin number 6 is my charge, CHRG, and it is also having bar. Then we go for this one as feedback. Then we have mode. What else we have? We have EN buck, enable buck, okay. So buck converter will be enabled, and then at last we have SW pin, and pin number 11 I have kept it for my pad, so I will just put it as exposed pad. Got it? Now our aim is to arrange these pins in a proper fashion. So what I'll do is I'll keep VCC left side, so I'll keep it VCC here. Okay, then enable charge, I'll keep it here. Okay, if you want you can keep it to like spacings or something like that. Similar to that, I have mode, so I'll just keep it mode according to like I am trying to put it in typical application, so it makes it bit easier. Then we have one ground pin as well, so I think ground pin I have not put it here. I'll just see. We have programming pin, so let's say I will put programming pin here. Okay, I'll just keep it, I'll just make it little wider so that it can be looking good. Then exposed pad, I'll just keep it here. We have SW pin, so SW pin can be kept it like switching pin can be kept like this. Enable buck, so enable buck and battery voltage can be kept this side. So, okay, so both are together. Now we have feedback pin, so feedback pin can be kept at this SW pin. We have charge pin, so charge pin can be kept at this place, and SCPR pin which can be kept this place. So this is pin number 1, 2, 3, then here 4, 5, then we have like 6, 7, 8, 9, and we have 10 and 11. Okay, got it. So 11 is nothing but your ground, so what I'll do is it is nothing but my GND. So GND is the exposed pad, that is the ground pin. Okay, now as you can see this is looking very wider, so what I'll do is I'll just make it little smaller, so you can see I can drag it and everything will come inside. Got it? If you want you can keep your ground downward, so it looks good, and if you want you can keep it charged this side, so you can make little space, and this is how you can do whatever way you want it. It's up to you like how you are going to make your symbol look like very good. Okay, then very good thing that you have to do is you have to change the parameter PCB footprint, so that is nothing but 10 MSOP. It's up to like I mean people or the company standards, like how they are going to write down this PCB footprint. Somebody writes 10 MSOP, somebody writes 10 dash MSOP, somebody writes MSOP 10 or MSOP dash 10. So it's all up to the like designer. At the same time somebody writes the PCB footprint as the PCB underscore the part number. Okay, so this all are there based on the industry standards. Okay, next thing what you can do is if you want, if you are designing description and manufacturer part number, so you can write down by yourself analog devices, or otherwise what you can do is you can go to digi key go to digi key and find out that number, so LTC 4080. Okay, and here this is a very good method to write down all the parameters very easily. Okay, so I'll just put it lithium ion polymer, and or lithium ion is better I think. So we have 10 MSOP here, 10 MSOP is here. So you can see we have this IC, and this is the IC that we are actually designing. So this is the complete part number that is there, so I'll take it complete part number here, manufacturer part number, and then we have this is the description. So if you want you can utilize that way description, so it looks good. If you want you can add more items in here, but this is sufficient for you. And then value, if you want you can write it a little bit less number of characters, so LTC 4080. So this is how it is now looking a good method, and what I'll do is I'll just save it and you can close it. So in the circuit I am going to place that IC, so what I'll do is I'll just search for LTC 4080 has come, and now press it, so your IC has come here. Okay, now it's up to you like how you are going to design your circuit based on the application circuit, or based on the design that you have decided you can design the complete circuit. Understood? So alright guys, hope you have a good understanding now how to design the library that is needed, and how you can save as, or like how you can I mean change the what do you say, basically the graphs or the orientation of the pins or how you can add pin, all those things I have already told you. So you can see we have like USB A type or USB B type, all these have been made slowly. So it is not a one day job. If you want to excel in your circuit design entry, or like you want to learn how to, let's say you have already learned how to design the circuit, now it is next job is to enter the circuit in your schematic so that you can send it for your PCB layout design, right? So for that you must understand how you can configure your pins or how you can do the job, right? Let me give you one more example so that you can have a proper understanding. Let's say we want to make it 4-pin connector, okay? So I'll just take let's say same IC I'm going to take from my this thing. So let's say we have this IC and I'm going to make 4-pin connector for this. So I'll just press file, save as. I'll put connector 4-pin, okay? Let's say I'll put 1 so that I have already a 4-pin connector, so I'll just make it 1. Now the symbol name has changed. Now what I'll do is I'll just delete all of them, okay? Now what I'll do is for connectors I'll suggest you to keep 3 grids, that looks good, okay? So keep 3 grids and then go to place and place pins. So you can keep pins like this, pin 1 and then place number 1. So it is like pin 1, pin 2, pin 3. So we have, we have 4 pins. So I'll just put one more pin, pin number 4. Got it? Now if you want you can keep it little lower, so you have understood now. Now what I can do is instead of putting all these descriptions and all, I'll just delete them because connector can be from any manufacturer, any types. I don't want to keep it like this. So connector 4-pin. So whenever there will be a need, I'll just put that, and here I'll just put it connector 4-pin. And when I'm designing a circuit, I will just keep the exact footprint of the connectors that will be required, okay? So this is how I'm going to do the job. So let us say that connector 4-pin just now you decided, right? So this was the connector 4-pin you made, and you can keep it here. Now if you want to change the part number or change the ideas of this, identity of this particular connector, you can select a 4-pin connector from your design, and what you can do is you can put the part number. So let us say I am going to put a part number for this 4-pin connector as from Worth Electronics. So this is the Worth Electronics part number. I can put it. So PCB designer will understand, okay, this is the part number, I have to change, I have to find out this part number and understand what is this particular part number. So let me just show it to you in DigiKey. So let us say we have DigiKey here. I can go there and show it to you like how does this particular part number looks like. Okay, this is not available here, so let me just show it in Google. So it looks like this, okay? It looks like this. So you have Worth Electronics, go here and directly you can see it looks like this. So we have like 2-pin, 3-pin, 4-pin, 5-pin, all these pins are there. So whichever connector you want you can have, and this is having actually 2.5 mm pitch, okay? This is box type connector, okay? So alright, with this I think you have a good understanding now. Now what is the change that you want to make? Let's say you don't want these pins to be appearing there, right? So what you can do is you can go ahead at this your symbol in the library, double click that, and you can see if you select your pin, okay, let's say, so it is telling pin visible or pin name visible, all these things are there, okay? So those things you can make it non-visible. Got it? So that's the thing that I wanted to show it to you. So let me show it to you. Here it is pin name visible. So let's say I'll just make it not visible. So this pin name will not be visible. Okay. If you want pin number to be not visible, pin number will not be visible. If you want pin name to be rotated, it will get rotated. So all these things will happen. Okay. So I'll just keep it pin name not visible. So this is how you make changes. And once you make changes, then what is going to happen? You can update this. So what will happen is, in this circuit there is something called as design cache, and in this design cache what you are going to do is we have this 4-pin connector. So you will see that part number here, okay, part name here. So here it is, con 4-pin. Now you have made some changes in this particular symbol. So what you have to do is here right click, and replace cache or update cache. So replace cache means you can replace with another part. Update cache means if you change something, then you can update it. So you can update it, yes, then all these pins will go away. So you can see this has gone away. Understood? So this is how you make changes, and you can update your symbol if you had made any, like corrections or updates or something like that. Got it? Alright, so I think with this we are good to go ahead with library creation, and my suggestion is, as I listed out all the components, please make out all these components by yourself. If you do not have a part number, you do not want to create by yourself, you can always copy paste from the like existing symbols. So let me give you another example. Like if there is no symbol available in the library that I will be providing to you, what you can do is you can go to pspice, or sorry, place, and then pspice component, and actually TI has already given you like some components, let's say diode or NPN transistor and all these things. Okay, so you can place this NPN transistor and you can utilize this. Let's say if you want to have this transistor in your library, then what you can do is you can go you can right click this and go and put edit parts. Okay, so if you put edit parts, this particular symbol has come. What I'll do is I'll just copy this and I'll go into my library file. So let's say this is my library that is there with me. Now I'll just open one of the symbol that is there with me, and I'll save this as NPN transistor. Okay, and save it, and now I will delete this one and I will paste that graphic. So this graphic is pasted here, and if you want you can put it the number that you want, let's say BC847. Okay, so BC847 is one of the like NPN transistor that you can put. That's all done. And if you have some other understanding, like if you want to like change the PCB footprint and all those things, so you can do that. So let's say I want SOT 23-3, and other parts is like it is not value is LED, you can put it like a transistor. Okay, so this is how. And if you want to put exact transistor, you can keep description, manufacturer part number for your convenience. However, I'll suggest you keep transistor MOSFETs as a general like graph, so that you can always change their values separately. And this is how you can just close this, press yes to save it, and you will see you have your own transistor in your library that is there available with you. So you can find out, you can see we have NPN transistor. Okay, so you see same transistor is there with you in your library now. Okay, alright, with this I'll just close this particular session with designing the circuit entry and like library creation. Thank you.